Hello everyone, welcome to 7 Peaks Speaks. I think we're waiting for a little bit more people tonight, but my name is Patrick. I am the head of talent acquisition at 7 Peaks, meaning that my team and I are responsible for all the hiring of our employees. Thank you for being here. Let's start with a quick video of our company at first. So as a company, we organize a lot of events where we enjoy to speak about new technologies, but also share knowledge with anyone interested. Tonight we are going to talk about progressive web technologies. So you're going to have two of our senior web developers who are going to be participating and discussing about the progressive web technologies. The speakers tonight are Rafee and Ashish, which is going to join us a little bit later. But let's go quickly through information about our company. First of all, if you're here, I'm pretty sure that you saw us online. So please feel free to follow our pages, social medias, like, and you can get information about our next event, but also our opening position that we're hiring for. And as we mentioned, as we are a company who are growing faster and bigger, we are a company as well who enjoys with our employee to work hard, definitely, but probably harder. There's a lot of couple of events that we're doing, outing, weekly, monthly events, which is pictured here. We're doing a lot of physical activities as well, monthly, like sports, karting, badminton, volley, CrossFit, and also playing video games. And what we enjoy the most, eating a lot as well. There's going to be pizzas, there's beer already, so feel free to serve yourself. And here is a list of all the opening that we have right now across all the functions in the company. From delivery to QA to design, backend, web, creative QA as well, people, finance, accounting, and so on. So feel free to contact us or refer anyone who could be a good fit for our company with the link right there. Something else as well, we have an upcoming meetup next month, which is going to be talking about Azure Senior Air Podman and co-migration. So feel free to register for our next event. Now last thing, to improve, please feel free to fill your feedback at the end of the meetup, and you'll get as well free pizza and beer. Now let me invite Rafee, who's going to be our first speaker. Welcome, Rafee.
Thanks, Patrick. Hello, everyone. Thanks for joining. So today we'll be talking about progressive web. So here is me, Rafee, senior web developer at 7 Peaks, and I have 5+ years of experience, and I like to solve problems and explore new technologies. And so today's agenda, first we will talk about what PW really is, then going some comparison with website and native apps, and talking about key principles, capabilities, and we will be talking about some building blocks of PWA. There's many page static server and talking about scattering strategies, best practices, limitations, and share some resources and tools. Okay, so if you want me to say in a word, what's PWA? It's a way of building application from one code base to all the devices, for all the devices. Like you can imagine the devices where a web browser is installed, like iOS or Android, from laptop. If you want to talk about desktop application like from Linux, macOS, or Windows, etc. So all the devices. It's one from one code base. You can run the application in various types of applications. So yeah, so moving here. So in PWA, the terms is P, W, and A. So the web W part is talking about the languages. So it uses the web languages like HTML, CSS, and JavaScript. And app means that it's not a website. It's building our real life applications and what you use in your devices. And progressive, the term progressive, P from progressive, is progressive enhancement. Is a design philosophy that's talk about really means that it's progressively enhanced to adopt multiple capabilities of devices. Like in mobile devices, there are some capabilities. In if you are talking about technology like laptop, they have their own device capabilities. So it enhances progressively to match the device capabilities. That's progressive enhancement. Like if you have the mobile browser, it has some capabilities, and moving forward with other devices, it will adapt these capabilities, taking the minimal content and functionality to all the users. And so now it's a website, definitely a website, PWA's website, but it has more than a website. So let's talk about the website first. So what's the characteristics of website or what it offers? Like linkability. It means that you can share your website link to anyone, and anyone from anywhere can access those links, and you can bookmark it, etc., etc. Discoverable by search engines, like you can search your website by Google or Yahoo, whatever, and it's secured by HTTPS. That's website, normal website that we are using frequently. But in PWA, it has some additional features. So by installing a PWA, it has their own icon. Like you can, if you are Windows, it's icon in the taskbar and start menu. If you are using the Mac, then it has the dock, or in mobile devices, it's home screen. So it has its own icon, any application. And standalone experience, like you will get experience of standalone window where it doesn't constrain into the browser tab constraint. So it will get our own icon and own window to experience. That makes our user more comfortable, that he recognizes your application by icon and he will use it as an app. Like you will get experience of mobile. And it has the ability to integrate the OS platform integration and much more advanced capabilities. So now talking about native apps and PWA. So in native apps, so if you are talking about native apps, it has different languages. For Android, you have to do it with Kotlin. For iOS, Swift, and for desktop application, you have to follow some other languages like C++ and so on. But PWA, it's only one language, like web languages is JS, HTML, CSS, and so on. And for native apps, it has one code base per device. If you are building for Android, it's only one code base for Android and separate code base for iOS. So one code base per device. For PWA, it's only a single code base, and it will be building for all the devices. And as there are multiple code base, so it will be multiple executable. After building, you will get that executable. And for as it is only one single base, it is only one hosted app. Like when you publish your web app, it will be only one hosted app somewhere you will host. And the third part is approval process. So when you are building a native application, it must has to go through the approval stage of the app stores. Like if you are building for mobile Android, it will be Google Play. But for PWA, it doesn't need to be. You can, but it doesn't need to be pushed to the app stores. You can push it to host it on a server, so it will be distributed through multiple devices, and so immediate update. So you don't have to waiting for approval process again to update and push. So we talk about the differences between the native apps and the website. So we got the understanding that the capabilities, in terms of capabilities, native apps are way higher than the normal web app because it has the capabilities to integrate things with the devices. The devices have the capabilities like camera access, geolocation, and so on. So in terms of capability, native apps are superior. But if you think about the web apps, it doesn't have that capability. So it's in the y-axis it's down. But for web apps, in terms of reachability, it gets higher than anything else because you can search it by Google. You can get it to anything else. Sorry for the notification. So yeah, so in terms of reachability, it is way higher than native apps because for native apps, you have to install it. You have to have the device at first, and then if you have the device, then you have to install it. Then you have to run the application. So in terms of reachability, it doesn't make much easier. But PW comes there to get the best of both worlds. Like you can search it with Google, and you can also get the capabilities of the devices as well. So and also when you publish it PW to the App Store, your reachability will be gone far than the web store's website as well, normal websites. Okay, so keep talking about key principles of PWA. So these are actually the combination of both principles for native apps and for websites. So I already talked about progressive. So it's actually progressively enhance the device capabilities and responsiveness. It's a key principle of the websites. Like it can be support all sizes of the devices and network independent. It's a principle of native apps. Native apps can work independent of the network. It can work offline and app-like feeling. Like you will get a standalone window, and you will get our own icon. That's app-like feeling. And the fresh, the part is a website capability or website principle that you will get all the time fresh information. When you build something, when you push something, you will get fresh information. So all the time PWs are fresh. And the safety is ensured by the HTTPS. You can't actually run the PWO on HTTP. So it's all the time it's secure. And it's discoverable by Google search engine or Google or whatever search engine, and re-engageable. It's a principle of native apps where you already know that you will be re-engaged by push notification or badge. So that's how users are re-engaged every time they are inactive. So it's also possible in PWA, and it's also a principle. And installable, like native apps, you can install the apps and add it to your home screen or so. And linkability, I have already talked about it, the linkability. You can send the link to anyone, and anyone can access these links. Okay, let me close this thing. Sorry. Okay, so so capabilities. So the list of capabilities beyond the reach of our talking is like 100 or so capabilities. I will talk about some interesting features or interesting capabilities of PWA. So moving first is run on login. So when you log in the laptop or desktop, you will have the option to run your application on start. Like you can configure it on the Chrome. I can show you. So here, one of my application is demo app. So I can run it on web app when you sign in. When I click this button, Then after I signing in, the application will be turned on. That's run on login. It's a benefit of PWA, one of them. And the second one is shortcuts. So it allows you to add deep links to your application from taskbar or so. So let's try to see these things as well. So I have this installed my application. When I have this button, you see that I have one shortcut here. If I click this shortcut, it will not open in the browser. It will open in my standalone window. Here you see that I am in the share web share page. So I can deep link to my application through shortcuts. And web share. So web share is you have the option to share the content with other applications or the vice versa. You can say you can get those information from the target. So another application can go to your application by web share. So to show you this feature, so this feature is not supported in Mac, but it is also supported, but it's supported in Mac. I have the simulator maybe. Where's the simulator? Okay, here. You see that I have the shared text here. If I click those things, you see that I have option to share it to other applications. Okay, for example, if I set the reminder, you will see the custom, I have sent a text which is linked here. I have a link which is also sent to other applications from application. It's also possible with PWA. Okay, the next thing is badging. So badging is for re-engagement. For example, you have some messages to unseen, then app is notify you that you have 2 messages, for example, in your application you have not seen yet. So you can do it with navigator set app badge. For example, in my application you have already seen that there is my demo, right? So if I go to set a badge, for example here, you will see that the T is appearing here, right? So it means that I have something I have to re-engage again to see what's missing. And you can also clear the badge as well. So it's controllable by your application. And it's a very good thing that much feel you like an application, real application. So it means that you have the capability to you utilize all the spaces of the web application. Like you have the header of your application, for example here. So I have the header, but you can customize this header to add more information to here. Like this title will be gone by here, right? Like this way. I can customize this title bar as well. So I have full control of my window to customize my application to feel like it's a real life application. Real application, not just website. So it provides classes, classes properties and events to manage all the things, like if it is shown here, or if the resize is there, I mean the browser is resizing or Windows is resizing. Based on that you can customize your title bar as well. So background sync is also important for it enables the data to save online and sync when it's offline and when sync it when it's online. For example, you are into filling up a form. So in the middle of the form, so you are going offline. So after you save, click the save button or submit button, it will not save because there is no internet there. But you can utilize the background sync API to make it more. Sorry. Please don't put messages. It's out of this time. Okay, background sync. So you can utilize the background sync API to make it save into your caching into the browser, and then when it's online, it will push it to the database or the backend or server. So it will not hamper the user experience, hamper the user flow. So whenever you are offline, you can work as previously what you do when you are online. And there is one thing, another thing is you can also sync it periodically. For example, you want to refresh your cache within 1 day after 1 day, or interval of 1 day. So you can also do it with background, a periodic background sync API. And push notification, you all know about push notification. It's re-engage user with useful messages. It's actually combination of two technologies: push messages and a notification. So push message means that you pushing some information to the user when you need to engage it. For example, you are not actively using your application. Maybe you are in another tab, or you are not in the browser as well. So you can push those notifications to your user that something is coming, something has come to your application. Please revisit it. So let's see something else here. So I'm doing it here in the browser. Here. So I mimic something like that. Oh, the demo is not working. Oh yeah. I got this notification, right? So here you see that this is my application name, localhost 3000, and this is the notification, and the message is here. So I can also clickable these things and deep link to my application as well. So the push notification is very important to re-engage user. So which makes it better for user experience in terms of user experience. And it is done by service worker and some events. So we'll talk about this later. And so it's actually a complex task. So the first thing is you need to ask your browser user that, do you want to get the notification? You already see in some websites when you go to the website, it's asking for notification messages. If you enable it, then it sends the client information. It's called rapid key, specialist key, to identify the browser session to the server. So server saves it. So and then server push notification when it needs something to show the user. Then the client will get the messages. And with notification API, you can show this messages to the browser that I have shown just a few seconds ago. And so offline support, it's a very important thing for making the process all the time, even if you are not in the network or your internet is stable. So you can render the contents and interaction when you are offline. So you can do it we can utilize some caching strategy. We will talking just a few minutes after, and it can be done with the service sort of functionality. Let me show you example. So I'm in a browser where there is a website. So where is this one? So if I am going to offline, so it will not show something else, anything, right? But if I refresh it, it can operate independently. That's like you can do what you can do with your app. So it's also possible in offline, and it's engage the user that make it more user friendly for user to work with their application toward whatever the network connection is. So its offline support is very important feature for PWA. And the next thing is file system access. So within the API, you can access your file system and write information in the file system as well. And the second thing is protocol handling. So you already know something like mail to. When you have some links in your website, it will open a mail shell, and you can send some information there. For example, if you are mail to, and it will be filled up the mail information you send here. So it's called protocol. This type of protocol can be handled by the application as well. So you can do it with manifest.json. We will talk about manifest later on. And the link handling that I have already talked about, that you can send some link. For example, if you have some link that can be opened by your application, it's also possible to do it by your application address, like the host address, like www.something. And link. So it deep links to your application. Did I miss anything? So yeah. So these are few capabilities I have talked, but if you remember, there are a lot of capabilities, and I will share the capability tracker later at the last. So you will get more information there. So that's from websites, so application. Device related capabilities, you will get all those things like have web API, and it's also growing up. So the community is doing good things, and Microsoft and Google comes together to make the PWA replace the device specific applications. So the next thing I'm talking about building blocks of PWA. So there are three building blocks. First is service worker. It's actually a proxy or interceptor between your application and network. So it sits in the middle of your network request, and it listens for the response as well. So it can manipulate things. Okay. Then second thing is manifest, and it's actually provides structured metadata about your application. We will talk about it also. The third building blocks is HTTPS. Without HTTPS, you can't run progressive web app or service, anything. It will not work. It also supports the supports localhost, and if you publish it, you must have HTTPS because to make it more secure. Okay, now manifest. So it's a single JSON file which tells the browser about your PW application, what it would be, what's the shortcuts, or what's the icons. You can define all the things in your manifest, and it contains the other information like what would be the theme color. You can adapt those theme color from your application. Like if your desktop you are using in a laptop or desktop, it has this theme, right? It can adapt those things in your application. So when you are in a light mode, it will be light mode. When you are in dark mode, it will show the dark mode. So you can customize this thing or sync your application with your device as well. So these things are defined in manifest. And yeah, so the second thing is service worker. As I have already said something about in normal website. For example, your website is not PWA, so it just requests to web application to the server when you have something to fetch, right? But with PWA, service worker is in the middle of your application and the server, and it listens for your request, and it can also customize something. You can get something from cache or IndexedDB in browser, and make your server call controlled. So when you are in offline, they can fetch these things from cache, or you can when you are back. I was already talking about the background sync as well. So the same thing. You request is post request, and it fails, but it has the option to intercept there and make it stored in the IndexedDB or caching. When you are online with some API, you can push it to the server. So you have the control here. Where was it? Okay. So the characteristics. So the characteristics is it runs asynchronously. That means that the synchronous systems like localhost or etc. PW can or service worker can't use those things because it's asynchronous, and it's run on separate process from your application. So if application main thread or main process is run asynchronously in one process, and from the service worker it runs on separate. It's a part of web worker. If you know about web worker, it's a kind of web worker. Service worker is a part of web worker, and so in a separate process, non-blocking. So your application will be separate process, and the service worker in separate process. So you can't access the DOM because the process is different. So the DOM access is not possible in service worker, and as it is in a separate process, when you are not active, it can also work, because if you are in normal website, if you go to another tab, it will not, the current tab will not work as previously. But with service worker, as it is contains in a browser window or browser, it will be working. Whenever you go anywhere, it can work. So, and it's event driven. There are a lot of events, and we will talk events later. But as I said, it only runs on HTTPS and localhost for security, make it more secure. The next thing is events. So there are two types of events. One is lifecycle events, and the rest of the things are functional events. So let's talk So SW life cycle. So there is a life cycle, as I said service worker is a life cycle from the beginning. So yeah, the service worker is written in a JavaScript file, for example sw.js, and whenever you add it to your index.html, it will be it will get to the browser, and it's trying to parse it. So if the parsing is successful, then it goes to the installing step. In this installing step, there is a install event first. So you can do something in between. Like when you are installing, you have the event that I have the install event. I can prolong it, or I can do something. In typical cases, we cache our pre-cache. So if you want to have something in pre-cache, it is the time, is the event you can do it. And after installing step, so sorry, it might be installed, not installing. The second step would be the installing to install step, where the PW is valid but not yet activated. That means you can't intercept the fetch, you can intercept the network request yet. You have to be activated before you get those events. So in activation steps, there is a conditions. Like if you don't have any other services, then it will be triggering the activating state. Otherwise, it will wait for finishing it, or there is an event called skip waiting to close the previous one and re-engage the activate the current service worker. So in activated state, there is an activate event is role, which where you typically want to do to render the cache what you have saved earlier. You can do it in that event handler. And in activated state, so the service worker is valid and is activated. Now you can get all the things like fetch events, other custom events you can customize, or you can get those events now. So service worker lifecycle is there. But in process where the installing and activating stage, if the installation is failed for some reason, for example your cache is not valid or something, it will be redundant state. So service worker will not be activated at that moment. So yeah, so service worker is activated, good, but it has the scope. So scope is where you put those put the service worker, it will only work on the directory, not the higher directory. For example, in AWS, AWS we are under the resource. So if there is something in about.html, it can't trigger or it can't listen for it. It only listens for resource folder directory. So it's the scope of the service worker. Yeah, very interesting event where you intercept the things. So intercept a network request. So whenever you are trying to call a network, it will comes into the place. The service worker comes into the game and hijack the request. Then you have the opportunity to do anything. You can either call to get the information from cache or IndexDB. Even you can return the custom request as well. So you have those capabilities in service worker, and you will return to the client with event.response with event method. So yeah, or you can also pass this to network as well. Okay, so yeah, it's I'm going to talk about the caching strategy. There are many caching strategy, and you can also adapt your own strategy as well. So the caching strategy means that when you request something, so you will not get to the network. You will always get to cache and return it. So it's important, or it's applicable when your data will not change. So for example, you get this data, you know that your data will not be changed anytime soon. So you can cache it. You can utilize this caching strategy. The second one is network only. So when it's applicable for when your data is all the time changeable. So there is no place for caching or anything. You need all the time the new data. So the network only is applicable that case. And the next one is cache first approach. So cache first approach is it looks for cache first. If there is any caching in there with that request, it will return the result. Otherwise, if it fails, then it goes to the network. So in 3B, if the cache is something, if you get something in the cache, you will return it directly to the client. Otherwise, it goes to the network and then return back to the client. So it's called cache first. The same thing is network first. It goes for network first and if the network fails for some reason, then it will go to cache again and then return the data. So it's important. So when you want to show some fallback things, so if your network is failed, you know something you have cached earlier, you can serve it from your cache. And the last one is still while validation. So it's a modern concept. We all using it in if you use React or something. So it will use this capabilities. So it means that for a better experience, you all the time you go to cache first and you return the cache first. In the meanwhile, it goes to the network and update the cache if there is new data. So so it's based on both world. You get the data first and you also update your cache regularly. So it's important for daily or most cases it's applicable still validation. So if those things are not not applicable for you, you can also customize your request. For example, you want to go to network first. Then if something happens or it's taking too much time, you can add a set time mode and add the data from the cache. So you have the opportunity to customize your strategy as well if those mainstream caching strategy doesn't suit you. So yeah, so the last part is here the best practices. So for better user experience, you should think in offline. So it might be happening that your user is not in good connection or might be in offline mode. So you need to utilize the features of PWA and make it workable in offline. In some cases, at least, not all the cases. And utilize the device capabilities. Device, as you have the capability to access the device capability, you can utilize it. For example, for camera, for geolocation, for shaking, there are a lot of things you can make it more user-friendly for a user. So you can utilize those things in your application to make it better user experience or better app feelings. And reduce friction is also important because a lot of users are going away because of long loading time. So as you already know about many caching strategies, right? So you can take one of those strategy and reduce the loading time or friction. That way your user will be more eager to use your application. And there is one thing, the Lighthouse. You can test the Lighthouse your PWA application that will give you a handful of information about your application state. Like it's also benchmarks things like if it is responsive or it's you give all the required icons. So the Lighthouse is very good thing before you go to production or somewhere. So it's also best practice for follow before your production. And yeah, as you already know that it can run on multiple devices from laptop to mobile and some other small devices as well, like as I have known Xbox, Xbox or Microsoft HoloLens. So they also support the PWA. So you have to test those things because it can be used in many places. So if something you test on mobile but not laptop, but if your user install it on desktop, it will not be good. So you need to test it before all the devices before you go production. These are the best practices. And the second thing is, the last thing is about the limitations. So PWAs started from maybe 2016 and now it's 2016. So it has they are working so hard to make it like as I've said, Google and Microsoft are working together to make it to adopt more capabilities into PWA and in Web API. But it also lacks of device capabilities, many device capabilities. So it's on one of the limitations. The second one is the compatibility with the iOS. Apple somehow they are not too much interested in PWA, but there's the one problem. So many features what you see that's not working in iOS. So it's a problem, but silently they are working to, as I have heard or read some articles about the Apple, they are also silently supporting those things in Safari. And yeah, that's legacy devices as it is coming 2016 or 17. It has also problem with the legacy devices. And yeah, the performance limitation, because when you build a device-specific application, like you build it with Kotlin or Swift, you can utilize all the things with your application because they support those capabilities in your application. But with PWA, these things are not that much friction-free. So performance is a big problem here. And so those are things, but the good thing is that they are working it to make it more suitable and add more device capabilities into PWA. In near future, maybe it will. Where's the slides? Okay. So we can hope that the gap between the native web applications and web app will be reduced in the future, because if it's possible, then we don't have to rely on one code base per one device, right? And so I'm sharing some useful tools here. So Workbox is very good a set of modules where each module will cover certain types of capabilities of devices. Like it has the offline service, it has the it has other 2 or 4 capability set modules. In each modules it covers a certain things. Yeah, so you can use the Workbox. It will simplify the raw code into useful APIs. So it will be much easier to work with Workbox. And Lighthouse, as I have already said earlier, that Lighthouse is super cool. You can get your statistics from your application, that is it good or is there some latency there. You need to make something to make it more user friendly. Like if you don't provide the theme color, it will ask you that you didn't give the theme color. If you add it, then it will be you will get better experience or better benchmark. And PW Builder, it's a PW Builder Studio. It's a VS Code extension, which also when you're building things up, you can also see those those metrics in your extension in a window. And PW Builder, there's another website. It's also useful for publishing the PW to web store. Currently, it supports Android and Microsoft, but they have the experimental support for publishing it to the Apple Store, Apple Store. So they don't guarantee about it will be successful or not, passing the category of the criteria of the Apple Store. But it's they are experimental stage. Hopefully, it will be stable soon. And manifest generator, as you have said, saw that there are certain types of things you need to provide in your application, in your manifest.json to understand what's all about. So it provides a manifest generator will provide those fields, and you can fill it up to make it more easier. And maskable.app is important. In some devices, the icon is square, your application icon in taskbar square. Some are rounded. So if you want to have supported all the things, all the devices support, then you can upload it to the maskable.app. They will generate you for the maskable. So it's also helpful. It's helpful tools. Okay, okay. So I've shared some resources here at sco.pe. It's a directory for PW apps. There are a handful of apps there. So all the apps are there are PWA. So you can experiment with it. That I have shown the Sudoku app was one of the app from App Store, and you can publish your apps PW application to there as well. So and the PW builder, as I have said, that it's also it's using for building application or publishing application. It's also good for your learning, because there are certain like sections where you can learn about PW capabilities and their experimental codes. And scoring, after you when you try to publish it, you have to give your link, website link. Then it will generate some scoring as well, like Lighthouse. They also provide information about your because they have to comply with your App Store, right? For example, if you publish it on Google Play, they have their criteria to be met. So they also provide those scoring there. So if certain things are not suitable, then this place will be helpful for you. And web.dev is totally for learning. There are a lot of sections, and all the things are there for learning, and also a list of capabilities. And there is a Microsoft 30 days of PWA. It's also a good place for learning, because they have provide the glitch, so you will get the runnable code there as well. And Google Tracker that I have talked, that is a capability tracker. So you will get those things like experimental. There are 4 sections: green, yellow, and 2 more things. So this means that how much browser support they have already given. So you will get those information, and the recent capability was the state of the capability integration of Web API. You will get this information in Fugu. Yeah. That's it. Then the conclusion part is that I have already talked that it's going to reduce the gap between the native apps and the websites. The gap between them will be reduced, and using the right tools and strategies, you can provide better experience. As I have said, that talked about some caching strategy and some tooling for like workbooks. So you will give more better experience for user, friction free, and so on, and get better reach by publishing to App Store, because you are indexed by Google search engine, but you get more reach when you have that application in App Stores, right? So so your application should be more reached by the people if you publish it. So it's you can often do it. And reliability, because when you install an application, that means that you have the faith that they have already passed all the criteria, right? So it's secure, it will protect their privacies, and so on. So it's reliable. So if you publish it, then the user will feel more trust on it, that the application will not do bad things. And re-engage user, you can, as already talked, you can re-engage user by badge or push notification and so. And the last thing, so hoping much better support for browser capabilities in near future, so that we don't have to rely on one code base per one device. Anyone? Dennis.
Thanks, Rafee. Nice.
Thank you.
Yes. So I have one question. So do you have any good examples of apps, PWA apps?
Yeah,
or
Spotify.
PWA that are out there in the wild, you said?
Yeah, Spotify, Twitter.
Yeah, are they actually kind of like the main channel where people use the app, or mostly people actually install the real app from?
Okay, okay. Let me show you the example. If I go to Spotify, so I have already installed it. So you can install it here. Okay, so when you open it, it will be open in the PW. You have that option. So user will either, if you don't want to go to a website and download it, then you can do it in a single click or 2 clicks. So you have that option, and Spotify also have the other things like they have the Android apps as well differently, but it also support the PWA with low cost. Like if you are in e-commerce, you are building an application from you are going to go market very quickly, then it's a very good option to start over your supporting all the devices. And if you need more device capability support, then you opt for device specific applications. As you need.
And it kind of takes me to the next point, is that I think it seems like PWAs are more useful for desktop right now because you're able to kind of get this app experience without going to the website every time. Whereas with like mobile apps,
the same thing. For example, you like the website. I build the website. You like that website. So you want to have that website in your home screen so that you can go very quickly and you get all the features without going to browser tab again.
But what about the performance and so on? Like people on mobile apps, like usually, they're used to like good performance, and PWA not going to provide you that, right?
The way you feel the experience with the web browser, you will get all the things, the same performance. But as I have said, if you have if you integrate some things like that closely related to the device, or integrate device APIs that doesn't support the equally with the PW and device application, because there's difference definitely.
All right. And so, like the final question, then the client comes to you and says, "We need an app," right?
Yeah.
When do you actually tell the client that you need to build a PWA instead of like going for an app or a website?
Yeah.
When do you tell
I have already answered, because when you don't have to access all many deep level features of PWA of devices, you opt for PWA. Because for example, in e-commerce you can do it, because in e-commerce what do you need? Like what device capabilities do you need? Maybe 1 or 2 camera or something. I'm not sure, to take pictures.
I hope not.
I have not. So if you consider as an e-commerce site, PWA is a good option to go for.
All right. Thanks.
Sure.
So this is somewhat similar. If you're just talking about like cross-platform mobile apps, so PWA has been around a while, but now there are newer things like Kotlin and Blazor and things like that. And things like Kotlin seem to have more apps now than PWA. I mean, can you explain why that is? And do you think PWAs will come up and be more popular in the future?
Definitely, I hope so. Because why you don't want to choose PWA? Because it's newer, and as of Kotlin, it's established long time ago. It's already experimented things, right? So as a business owner, what do you need? You need the reliable things, right? So and for this reason, the Kotlin is also dominating right now, not the PWA. But after growing the capabilities, APIs, web APIs, increasing the APIs, it will get more attention in developer community as well. So does it? I'm not sure what you want to know.
Thank you for the presentation. I'm not a front-end developer, but when we add this PWA to the desktop, for example, Windows, it will like a wrapper on the browser, or no? It's working on different layers.
It's a very good question. It's a browser. So it actually runs on a wrapper, but inside it, all the things are browser. So let me show you one. So it's a PW application of Spotify, right? So you will get all the things. I have the browser extension, and I can also get the Chrome's things as well.
Okay. So actually, this is a browser.
Yeah.
Okay. My second question was about some permission from the OS. For example, you want to use this PWA as your desktop application.
So you tell your users to use this PWA, so they can add this PWA every time, no need to open the browser and open just that PWA. So, I mean, is there any issue with the, for example, opening the camera? Because camera needs some permission from the operating system.
Yeah. It will ask for the camera permission. If you go to the Google Chrome, so if you see there's things.
Yeah, I know about the browser. So this PWA works exactly like the browser.
Yeah.
Okay.
So, yeah, because when you ask for the permission, it also gives the permission for the browser, like the push notification as
okay. Good. Thank you.
Anyone else?
I'm not a developer, but I have a question. Because normally when you download app in a certain country, right? But if you go to another country, it will be region specific and will be restricted to download. Is there such a limitation in PWA?
Okay, so how does that work when you switch the country and restrict the application? Like you have the you know the IP address from the user, that where he is right now, and restrict those things by the development, right? So you can do it with our application as well. You have the IP, you can access the IP address from the client, and you can do it. And the other thing you talked that the visibility of the app stores, right? Yeah, you can you have the option to do it with the publishing of the application builder, PW builder. That you are restricting it for one country and not other countries. So you cannot restrict it from. You can restrict it from downloading from the website. If you do it, you have to do some if condition that if your region is like that, so don't add the other things, the PW logic there.
So if I want let's say I want to build a PWA of my company, and I want it to be not restrictive in any country, is possible.
Restrict any country, I mean, you want to restrict other people to use your application.
I want maybe more than one country to be able to install it without any problem. No restriction.
Oh, you don't want to add no restriction.
Yes.
Yeah, by default it's not no restriction for application like your website. For example, you host an application somewhere else. Everyone can use it, right? Anywhere from across the world, right? This is something a browser, but it's somehow something inside it to make it like fill your application. It never be a like device application. Not never like that.
Cool. Thank you.
Thank you for your presentation.
Thank you, sir.
We have one question. Is it possible like transferring file to the server
Transferring file. Yeah, you can transfer
using
image.
PWA?
Yeah, you can transfer image as I have shown that web share.
Yeah.
There is one capability to share. You can share links. You can share the text that I have already showed in demo. Like you have something in there, right? Inside the share text. I have put one link and one text. So if I go there, then I can share it to available application that can open this. So if I open this, then my text will go there and work and will be here. So and you can also transfer image files, video files. So that you have to support those things. I mean, you have to tell this. This is file, image file. This is link. There are the properties with the web share.
But this one is based on HTTPS protocol.
Yeah.
And can we use the protocol like a FTP protocol?
Oh, you mean that you want to access the file system? Yeah.
Like a file system transfer to another system.
Oh, you mean that yeah, you can read those information from the server. Okay, you want to copy one file, and what do you want more?
From yeah.
There. So you need to do first thing. You need to access the file system API.
Yes.
Get the file in your system.
Get the permission from my system.
Yeah, it will show the permission. Permission.
Yeah.
As I have, there is an API for. 1 second. Yeah. So show open file picker. So where you pick your file, okay, and it will be in your application. Then you can pass it if you want to pass it somewhere. It's up to you. It's in your application, right? And you can also paste. You can also save it as well with the save open file picker.
Thank you.
So many questions.
Sorry, just one thing came to my mind. This PWA, think about this situation that I have Edge browser, Firefox, and Chrome. So, as we know, maybe there is some limitation based on the Firefox or Chrome.
Yeah.
So, if I add this PWA from the Firefox, after that, it will again use that Firefox engine or some Chromium engine. So, I mean, based on your situation, maybe you have some logic. If your code run in the Firefox, you have some condition for enabling something or some limitation. My question is, if I had this PWA from the Firefox, again, it will use that Firefox browser for the rest of the life as the PWA.
So to answer your question, so for example, in your Firefox, this API is not supported. Say at best is not supported. So you can block it. Like if if the browser, wherever I am, doesn't matter. If I have that thing in my navigator, then I will do all the things, because you see that if you know about the React, I set it in supported in here. I disable the button, so I will not operate on it.
Okay, I mean, if I have the Chrome browser as well, but I install the PWA from Firefox, it will always disable such these features.
Yeah, because if there is nothing.
Okay. Thank you.
Okay, so we have to close. Thank you. So I'm passing my vote to Ashish.
I'm asking question.
Okay.
What if we delete the browser?
Uh-huh.
What happens to PWA when we delete the browser? Like remove the browser from the system?
Delete the browser.
Yeah.
So no, you already have that. You have already do these things in your application, right? So when you delete this application, so let me show one thing to make it more. So it's also saved in Chrome browser directory. So if you delete your application, then it will also delete it from your doc or everything else. So now this is okay. Let me just tell you that this is actually stay inside the Chrome apps. It's a Chrome app. If you delete the application, it will not work. So you must have that thing in your application.
I mean delete the browser, not the application.
I mean delete the Chrome browser. I mean,
Yeah.
that one. That when you download it, it's also a part of web app inside the Chrome. So as you have already accessed those things, you can. If you delete the Chrome, it will not work anymore. The application will be removed from your laptop or whatever.
Thank you.
Thank you so much. So I'm passing my floor to Ashish, who will talking about the WebGPU and WebGL. Thank you so much.
Just a minute. Maybe 2. Please drink. Are we allowed?
What's a Milo machine?
Yeah, it worked.
What's a Milo?
It works on my head.
What's on my screen?
Thank you. Let me quickly test this. Hello everyone. Like that. It's too bright. Hello everyone. My name is Ashish. Today we'll be going back to college and learning about GPU, graphics programming, and something more. Before we start, I want to make an Instagram post. Can you please pause or something? Give me a second. Yeah, you guys can pause if you want to. Where am I or something? You can keep having drinks. I'm just. No. Well, I messed it up, but it's on. So back again. Where did I put the remote? Okay. So first, the introduction part. So we'll be going through what a GPU, CPU, and graphics APIs are. So we'll be talking about, like, this is back to basic kind of thing. So let's go. What a GPU or a graphics processing unit is a specialized hardware that was originally designed to accelerate 3D graphics. So what the GPU was meant to do was make 3D faster on computer, because doing 3D on CPU was really slow at like 90s, and they said, oh, we need a special hardware for it. So they designed something called GPU. But over the years, GPU was updated, like, to make the 3D faster, and at one point they thought, like, we can do much more than like run 3D graphics on GPU. We can actually do processing on it. So now modern GPUs are like designed so well, they can actually process pretty well, like along with doing 3D graphics. That's still there. So what, like, before we talk about what modern GPU can do, let's start with what parallelism is. Parallelism. The term parallelism is basically when in computing, the term parallelism is basically when you have two different part of a hardware doing separate tasks. Like, you can think of it as, in a multi-core system, two different code executing different pieces of code. The code have to be different. That means, like, you are running a Spotify, YouTube, or something on your computer, and they are being, let's say, they are being executed on different parts of your CPU. That's what parallelism is basically. So, like, in the world of computer, there are generally two forms of parallelism. You can have something called task parallelism and a data parallelism. Basically, a task parallelism is when you have like multiple tasks running on multiple parts of your CPU. Like, these are generally regarded as different block of code or different pieces of application that are running in your CPU at different hardware parallelly. That's what we call task parallelism.
basically means your CPU is doing two different things at the same time. But like what data parallelism is, you're like running same operation on multiple data. That basically means you have like same operation, like same piece of code, but the data is different. That's what a data parallelism is. And GPU are really good at it. Like they're so good at it that we like kind of need GPU to be present in our modern hardware. So that's why they have something called iGPU now. So where is data parallelism is used? You might ask the question. It's used everywhere, from computer vision, machine learning, AI things, to encoding, decoding video. So it's everywhere. So GPU are kind of very important thing now, along with CPUs. So that's all. Like when we compare CPU and GPU, CPU is kind of like a jack of all trades. You can do anything on a CPU you want. You can even do data parallelism on a CPU, not at the scale of GPU, but you can do it. So it's like a jack of all trades. You can do anything you want. But as I said, like data parallelism is so heavily used in our modern computing that we have iGPUs in our CPU. They are a part of the CPU that are dedicated to being GPUs. So, and the main difference between GPU and CPU is CPU will have like some few cores, like 8 cores, 16 cores. GPU consists of thousands of tiny powerful cores, not powerful, sorry. So this is what is like a basic difference between a GPU and a CPU is. You can see it's a fairly decent CPU with 6 core and 12 thread, but while RTX 3060 has 4000 CUDA cores, that's computing cores, and each of those cores are clocked around 1.41 gigahertz. So CPU has higher cores. CPU has low number of cores, but they are very powerful. While GPU has higher number of cores, but they are low power cores. They can't compute much, but there are a lot of them. So this is a basic difference between CPU and GPU. So am I going up? Sorry, I pressed the wrong button. I'm pointing here, but I should be pointing here. Sorry, sir. Yeah. So, like let's say, okay, what we are talking about is programming GPU. This means basically we want to perform our computation on GPU. Normally, we developer like execute, like write code for CPU, right? This is when programming GPU comes, is we are writing code to like to be executed on GPU. Like our code normally get executed on CPU indirectly or directly. And there are two forms of GPU programming. One is graphics programming, that's like the usual thing, and the new one is GPU programming. Graphics programming is for like if you want to draw something with the GPU, it's the original purpose of the GPU, like making it's an accelerated hardware that can generate images as fast as possible. But the new thing is GPU programming is like I want to do any computation on GPU. That's like general purpose computation for anything. Let's go into graphics programming because that's the main part of this talk, because we will be going through WebGL and WebGPU mainly. So what graphics programming is basically making GPU spit out pixels. Pixels meaning images. So, and as we know, our image is basically an array of data. Here you can see there's a basic image, like it's black and white. 1 is white, 0 is black. So it's just a grid of data. So we need heavy data parallelism to generate or process images in a large quantity or videos. That's why GPU are so good at drawing images or processing data. Okay, so to program a GPU, you basically have to use API. Why? Because there are multiple vendors of GPU. You get GPUs from NVIDIA, Intel, AMD. So those all GPU can work on a common API. So those are known as graphics API. So there are a lot of graphics APIs, and each platform needs an API. So there is something called DirectX from Microsoft. There is Vulkan, which is an open standard. There is meetup for like Apple devices, and for web there is WebGL and WebGPU. Like among all these API, I'd say WebGL and WebGPU are the most cross-platform ones because they are on the web. The browsers run them, not the OS. So everyone agrees to like And so since Chrome and Firefox literally run everywhere, that means you can run WebGL and WebGPU everywhere. So these are the graphics APIs. So basically to program a GPU you need API, and those APIs are known as graphics APIs. So WebGL was a revolutionary technology on the web, because before WebGL, like we could not like even imagine doing 3D or an accelerated image generation from 2D or something on the web, right? But after WebGL in 2011, it's suddenly magical. You can have your e-commerce site or some site do 3D models easily. So it was a revolutionary technology for the web. And WebGL is based on the OpenGL ES, which is the mobile version of OpenGL. So now we have WebGPU. Chrome like just made WebGPU standard. Like by standard I mean not what we do. They just released WebGPU 1.0 on production, so you can use WebGPU on Chrome. So it's a successor to WebGL, because WebGL is really old now, kind of old. So let's go through how we can how the whole process of generating an image on GPU with a graphics API goes. So it's a series of steps that we developers or the GPU does to generate an image, accelerated image on demand. So let's check. Look, this is basically called a graphics pipeline, and it's the heart of modern graphics programming. So it doesn't matter what API you use, but you will see this everywhere, because this is how basically the APIs and at the surface level how the GPU actually works. So this is the pipeline for both WebGL and WebGPU. Other graphics APIs might have slightly different pipeline, but it's always this. You'll see this structure everywhere. So this is a pipeline. That means we only control the start of it. Like we feed the data, and we can program. Like you see the red marker on 2 stages. Those stages are known as programmable. That means you can write code for those stages. Other stages are kind of configurable, but it's all up to GPU on what it does. So we prepare the data. So we'll be going through each of those steps one by one and understanding what they actually represent or mean, and how we have a final image from the GPU. This all happens on the GPU. So it's like basically how GPU works. So first step we call raw vertices. This is basic. What vertices are basically a raw geometric data. Let's say I want to draw a square on a GPU. That means the vertices for the square. So we just prepare our data for the shape we want to draw with the GPU. That's the initial thing we do, because I'll be coming back to this slide a lot now, because this is what we'll be talking about. So that's the first step. We prepare data for the GPU so that it can draw some shapes like a square for us. So in this talk we'll just be talking about squares mostly. Then after we prepare data, let's say I want to draw a square like that, and I prepare a list of vertices for the square. That's 0, 1, 2, 3, 4. I'll be talking about why we represent square as a 2 triangles soon, but let's just say you want to draw a square, and these are the list of points for the square, just the coordinates. And the second stage is what you saw called vertex shader. It's a first programmable stage. That means on what happens on this stage is entirely up to the control of the developer. So we write code for this stage, and the input for this stage is the raw vertices that we prepared, because it's a pipeline. Input comes and we process it, then we define what the output is for the next stage. That is primitive generation or primitive assembly. So on this step we can write code for what happens to the data that we defined initially. Right? So what shaders are? Shaders are basically tiny programs that run on the GPU. Shaders actually run on the shading code, the cores on the GPU. So shaders are what actually enable GPU programming. And there are like multiple shading languages called WGSL, HLSL, GLSL. But like GLSL, like this shading language depend upon the graphics API, but they are a lot similar to each other structure-wise. So yeah, it's just basically a tiny program that runs on the GPU. And this is what a typical shader looks like. It's actually running somewhere in one of our projects. I will not say which, but Yeah, this is what a typical shader looks like. It's a small program, but we'll be going through like more on shaders later. But this is GLSL code, so it's pretty similar to C. Next is, look, so we have first stage, right, where we prepare the data for the GPU. Like the prepare data, by prepare data, I basically mean we prepare a list of points for the shape we want to draw with the GPU. And the second stage is a vertex shader. It's basically a programmable stage for which we write the code and we can control the output for the stage because we write the code. That means you can control what happens on the stage. And third stage is primitive generation. So one thing is the output of vertex shader is always the updated position of the vertices, updated the next position of the vertices we initially defined. So we have this data, right? On vertex shader, we can write code to modify these points, like should they be multiplied by some time, should they be added by some number. We can do anything we want, like programmatically, but the output of the vertex shader should always be next position, like what this value should be next. But so then after that we have something called primitive generation or primitive assembly. At this stage, what GPU does is like build primitives. What primitives are? Primitives are like a scheme for the data we supplied. So we need to tell the GPU how to arrange the points we give. Like I just gave it point, like we give the GPU points, right? It doesn't know what the point are. Should it like arrange them as lines? Should it arrange them as triangles? Should it arrange them as polygons? It doesn't know yet. So on primitive, like there is a configuration, like we specify primitives along with the data. So we tell GPU what we want to draw. But you mostly it's only like generally we only draw triangles when we want to draw some polygons. Why? Because GPUs are by design designed to draw triangles as fast as possible. So no matter how complicated the shape is, it's always divided into triangles. Like a raccoon model you see, it's a 3D raccoon model, but is made up of triangles. Like you can have like a color texture for it, like you can skin it whatever way you want, but at the end the geometry will always be triangle because GPUs are designed to draw only triangles. So on primitive we usually specify triangles. That's why the square I wanted to draw, you saw this, you saw this, I wanted to draw a square, right? But I defined it as two triangles. It's because GPUs don't actually have anything to like, GPU won't let me like specify like draw me this triangle, draw me this square. Sorry. Like if I tell GPU to draw me this square, then there's no option on most APIs. So you need to like specify as triangles. And when you want to draw a complicated shape, like very complicated, if it's made of a triangle, it's much better because GPU can compute it much better. It will do it as fast as possible because by design they are designed to process triangles. So that's why I wanted to draw a square, but I set it as two triangles. So it doesn't matter if the shape is a path, circle, or a curve. You have to break it down to triangles. And this is basically what on primitives we specify what we want GPUs to draw. It can be mostly points, lines, or triangles. And for a complicated shape, we always choose triangles. And the next step is the most fun one. It's called rasterization. So now we up until now we were playing on the field of vectors. We were specifying point, line, triangles, right? Now it's like what the result, what we want the GPU is to draw as an image. The image is basically a set of pixels, so it's time to go to the pixel world. So and that's basically what rasterization is. It's the process of converting the vector data into pixels. So you see, like there's my set of triangles. There's a polygon, some shape I want to draw. It's a set of triangles. Now what GPU does is like take this shape and just computes whatever pixels fall on inside it and makes me a image. It's not a final image yet, so we call it a fragment. We call each of those pixels fragments because we still don't know whether they will end up in the final image or not. Why, you may ask? Because there's one step called testing. We need to test all those pixels or fragments. on whether they want to be on the final image or not. So basically, okay, let's go back first to the main slide. So we basically define set of points, like what we want to draw, a geometry, set of points. Then we fed it to something, fed it to the GPU. So it ran something called vertex setter, and it's a program that we define like what it want to do. And vertex setter outputted new position for those vertices, and those vertices were assembled to a shape based on our definition of what we want it to be, but it's mostly triangles, so set of triangles. So it assembled set of triangles from the vertices from the position we supplied. Then it moved to rasterization, where it's time to go to pixels. So from the set of triangles, it just computes what lies inside the triangle. It computes what pixels lies inside the triangle. So how many pixels the triangle should have, the set of triangles should have, and it forms an image. It's a temporary image because we don't know if each of those pixels are final or not, because it still needs to test it. And then there is something called fragment setter. This is also a programmable stage. In fragment setter, we can control what the color of a pixel will be. So the output of the fragment setter is always the color of the pixels, and the input, there are inputs, but we don't really care about them because mostly the above stage was not programmable. So the input for the fragment setter is just pixel, and output is the color of the pixel. Pixels comes from rasterization step, right? So this is on rasterization, we converted our triangles to a set of pixels or fragments, and these pixels or fragments get passed to the fragment setter, which needs to, we write code for fragment setter. We'll get that into later, but the fragments, basically the fragment setter outputs new color for the pixels. And the reason why I say the image is not final, or all the pixels in the image are not final, because there's one step called testing and blending. So you have seen a 3D world, right? There's objects might be near or far, and some objects might block other objects. So the GPU doesn't yet know which object is near, hasn't yet computed that which pixels, because even if we draw a 3D world, at the end of the day we'll be displaying it on a 2D screen. So it's like a grid of pixels. So first, before the pixels are finalized, the GPU need to test whether they fall in front or behind some other object. So as you can see in this diagram, there are set of triangle, rectangle, and some other shape. And if we want to, if we place them in the same screen flat, they all fall on top of each other, right? Now GPU needs to compute that which is behind or which is closer, because without it we can't say that this is the final pixel for this region in the screen. So that's why it needs to perform testing before the fragment is a pixel. So there are basically depth test, meaning which is front or behind. Stencil test is user defined. Testing against user-defined test condition. That means the programmer defines the test condition. And there is scissor test. Scissor test basically means I don't want anything outside of this rectangle to be rendered. You just specify a reason, a rectangular reason, and you can tell GPU if some pixels fall under this, outside of this rectangle, I don't want it, and it will just discard everything. And blending is basically alpha blending. So we just, as a normal web developer, you just set alpha values on the browser, right, to make something transparent or something. But when it comes to GPU, you need to actually take care of it. So you need to define rules for blending alpha values. So it's just configuration part. You don't have to write code for it, but you need to configure how alpha is manipulated. So that's, and finally, once we go through all these stages, the final image that's generated is stored on a special memory or a space called frame buffer. So that's just our result image. So a frame buffer is basically collection of buffers. By buffers I mean add or some memory space to store something, and it's just the destination for the GPU to write all the things it just drew, generated. The content of frame buffer is what we display on the canvas, window, or screen, whatever you may choose to, or you can generate it as an image or video if you want to. So it's just the final output is called frame buffer. Then we have this all these stages, right? All this pipeline. But how do we actually start it? How do I from this? Because when we write code to be executed directly or indirectly or on the CPU, right? So how does the CPU command CPU to start drawing? So all this happens through something called draw call. So a draw call is basically a function or some method given by the graphics API to you to start whole this flow. So what we do is we set up data that we want to render or to render a set of points for a set that we want to render, and then we specify the pipeline. By specifying the pipeline, I mean the whole steps we did. We specify what the primitive will be, is mostly triangle. We specify test and alpha configuration, how you should do depth test, how you should do some scissor test. Then we specify shaders. There are like only two shaders that programmable on WebGL, and WebGPU has one extra shader, but we'll talk about it later, and WebGPU. And we specify frame buffer, like where it should write all the images is generated, and then we just initiate the draw call, and that's a function that the API provide, and the graphics pipeline is executed on the GPU. And the one thing about this draw call is the CPU and GPU work asynchronous to each other. Once we start a draw call, the GPU is on its own and it will draw the frame. But you can wait for GPU like async or wait. You can we call it fencing or memory barrier. You can like stop and block the code and wait for the GPU, but you don't really need to. GPU can just do its thing. CPU can send some draw calls. It will queue the draw calls and just keep doing its thing. So CPU and GPU always like work in asynchronous way. And back to it. So this is the whole flow on how actually an image is generated on GPU. So like I promised you guys that we'll be looking into these two shaders in more detail. So now we'll look into these shaders once more and then look into the whole flow, because like these are black boxes for now. I just told you that they are programmable, and the output for them is something like output for vertex shader is the new updated position of the geometry which was supplied, and output for fragment shader is always the new pixel color or color of the image that was generated, but it's still a black box. So, and I have something else to say. Like at the start of this talk, we started with parallelism, right? I said like GPU can do heavy parallelism. All this pipeline, they will run in parallel. I give GPU a huge list of data, like thousands of vertices. Then it will split the input and run multiple of these pipelines in parallel and generate multiple pixels at the same time. So that's the level of parallelism we are talking about. Is a lot. So like they can run thousands of these pipelines. So there's a small video like the NVIDIA themselves did on how actually GPU works on drawing image. This, watch it.
Alright, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1.
This is how CPU works.
Let me speed it up. Ladies and gentlemen, Leonardo 2.0. When we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes within which the bottom up is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target, hopefully. When it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration. And 10,
9,
8, 7, 6, 5, 4, 3, 2, 1.
So you see it's pretty fast.
ladies and gentlemen,
That's how GPU works. They just process everything in parallel as much as possible. They just try to generate it all at once, not like sequentially or doing something. That's why they generally come with thousands of cores, like 4,000 cores. So yeah, all the pipeline you see for like billions of, like thousands of input, not billion, sorry. It just like they just ran in parallel. It's splitted, ran in parallel, and they just generate pixels in parallel. So like this is slow by the way. So this is a pipeline for WebGL and WebGPU. Those are the web graphics APIs. So let's see how a pipeline looks on a different API for Vulkan, which is for desktop and mobiles. It's basically similar, but there are some extra stages. So basically, Vulkan has three more programmable stages compared to WebGL and WebGPU, but the structure is same. My point from this is, no matter what graphics API you use, the pipeline is always the same because GPU works in the similar way. So from this, you can just get started with any of those graphics API. The structure is always the same. You might have couple of more stages on the pipeline, but the overall working on how they work is pretty similar. Let's see, like I showed you this data at initial, right? Like let's see how, like if I pass this data to the pipeline and like set vertex shader to basically do nothing and fragment shader to spit out only one color, then this is what the result is. I just drew square through GPU. But the vertex shader did nothing and fragment shader set all the color to red, because like those two programmable steps we can control. On vertex shader we can specify what the new position of the vertex will be, and on fragment shader we can specify what the final output color of the pixel will be. So I just say draw out pixel red and draw the square as same as the data you inputted. So I gave it a square, it draws a square with red color, basically. So because we don't know what shaders are exactly, right? We've never gone through them. Now let's just talk about the shaders, like which are like the gist of graphics programming. All the time you'll be spending will be doing better shaders, I guess. Programmable steps. Okay, WebGL and WebGPU only have two programmable steps on the pipeline. They are vertex shader and fragment shader. So vertex shader is basically a program that runs for each of the input vertices. So on square we like passed it like 6 points, right? Two triangles, so that's 6 points. So the vertex shader, the program will run for each of those 6 points. So that's basically what a vertex shader is, and it will programmatically allow us to set the new position of that vertex. That means the coordinate we passed goes through the vertex shader, and we can control what its next position will be, like updated position. The shader just updates the position of the geometry we supplied. And this is what a basic vertex shader looks like. So we have input variable, that's basically the vertex position. The two-dimensional position we just set ourselves and give it as an input to the pipeline. Then there is something called output variable. We will go into it later. And like when I set something GL position, I'm just setting the new position of the vertex, because that's what vertex shader is meant to do. And that position is output for the next stage. Output to the next stage, that means it's the input for the next stage, because it's the pipeline. One stage does its work and then passes the result to another stage. Then that result is input for the another stage, and that does some work and passes down to another stage. So there's something called output variable here. What output variable are, like on this shader there are only two programmable stages, right? But they are very far away from each other. Okay, here I see. Then one is vertex shader that we can program, and another is fragment shader that we can program. If we want to send some variables from vertex shader to fragment shader, then it will go through the pipeline. Like the only input that the fragment shader can have is from rasterization, because it's a pipeline. One thing processes, gives to another thing processes, gives to another, right? So this output variable lets you directly send input to like the other stage. So from the programmable vertex shader, I can directly send output to the fragment shader with the help of this output variable. It's kind of like a trick thing. So on the pipeline, because this pipeline, so we are just kind of hacking into same data, but it's not actually hack. It's a usual flow, like it's a usual pattern. Just they allow you to set output variable to send data to any of the other programmable states, because there are only 2 stages here. So this is it. The input, like this is a vertex shader. So the input is the input we specify. Like we specify the square. So that's the vertices, and output is the output for the next stage. We can do any form of computation here. So you can, like, I just like set the GL, like the next position to be the initial position, the input position, right? But I can modify it. I can just multiply it by some number, some time, or do some complex calculation. Just you can set it. So that means it can change in real time. So you can do whatever you want. So you can do, like, you can move it, you can do animations with it, anything, but it happens here. The magic happens on the vertex shader because we control the final position of the vertex. And the other is fragment shader. This is kind of cool because it runs for each of the pixels generators. So if you generate a 4K image, let's say you generate a 4K image on the GPU, the fragment shader will run, the program will run for each of those pixels. That's a lot of pixels it runs for. So it programmatically allows you to specify the final color of this pixel. You can control what the color of the pixels will be. So this is basically a fragment shader looks like. So it's the input, the output variable from vertex shader. I just take it as an input here. So I'm just sending data from one shader to another shader, and the frag color, that means just the output of this stage. It's just a vector for its color. RGB, so yeah, we can just specify. We can do much more complex calculations on it, but this is as simple as a fragment shader can look. And let's see what happens with these 2 shaders. Like, let's say we specify, like, with these 2 shader code on the pipeline, and with our data that we have for the square, that's the data, the set of points, 2 triangles, because we can draw triangles very fast, and the triangle is the, like, the primitive with the surface and area that it can support. Other primitives are line and point, and we can't draw area in a line and point, so we specify as a 2 triangle. And other reason, GPU can draw triangle really fast. So we have square as 2 triangles and set of points, and we have 2 shaders from above. So it will be something like this. But like you say, it's kind of different because we just add the position, which is basically for 0, the point here is the 0.5, 0.5, we add it by 0.5, 0.5, that means it's 1, right? But here the color looks smooth as to solid. The thing is, on rasterization, you see there are 2 triangles, right? GPU needs to calculate each pixels for the triangles. So any output variables you define on those vertices, it will interpolate it. So since it was interpolated, it appears smooth basically. So on rasterization, if you have output variable on the vertex shader, the GPU will also interpolate those variables for you. You can ask it for not to do so, but it will do it automatically. So let's look at the pipeline again. So this is all. So we specify some geometry we want to draw, or vector data we want to draw. It can be a complex shape, anything, square, triangle, even a 3D model, anything we want to draw, we specify it, and we like set that data in a memory, and we like start a drawing call, and we like say GPU to draw it. It will pass that whole data through something called vertex shader. That means for each of those points you had in the geometry, a vertex shader will run. These things are happening in parallel, by the way, but for each of those points you have in geometry, a vertex shader will run. And vertex shader is a programmable stage. That means you can control what happens on this stage, and the output of this stage is the new position for the geometry we initially shared. So after that, something called primitive assembly happens. Here basically GPU goes through the points and just converts it into set of triangles, because we needed to like know what area the triangles cover for us to get pixels out of it. So then rasterization happens. On rasterization, basically the vector data we had gets converted into set of pixels. Now it's time to go into the world of images, array of pixels. And for each of those pixels, GPU runs something called fragment setter that can control the final output or output color of that pixel or the fragment. And then we test those fragments, whether they should appear on the screen or not, whether they are blocked or not, whether they need to be mixed together because of the alpha. Then finally we store the final result on the frame buffer. This is basically how GPU draws or accelerated graphics works. So finally, there is one extra shader called compute shader. This is not supported on WebGL, by the way. This is only possible on WebGPU, which is the new standard for GPU on graphics API on the web. So what compute shader is? Compute shader is not the part of the pipeline. It exists separately. So on compute shader, you can actually do any computation you want, and they are general purpose. That's why they enable GPU programming. Other shaders are meant to be used inside the pipeline, though they are meant for generating images, doing some thing. But this can do anything. So these like most of the data processing logic you write in a compute shader. So they are just general purpose shader. So summary. So we went into what a GPU is, what it actually does. It does parallelism at a very high scale for data. That means we are applying same operation to a huge set of data. So same pipeline to a huge set of geometry data. So, because we want to generate a final image. So then we went to the shading pipeline or the graphics pipeline, which is the core part of any GPU or graphics programming on any APIs. Like we don't need to restrict ourselves to the APIs on the web. This is same principle for all the APIs. So then we talk about what, like we said, data. What a primitive is. Primitive is just basically scheme or like arrangement for the geometry data we send to the GPU. They can be points, lines, or triangle. They are basic. Primitive means basic. We only use basics. GPU doesn't. Some APIs allow you to draw polygons, but GPU by design are designed to draw triangles. So we always specify our set of vertices as a set of triangles for all the complex shape or 3D models you can find. This all set of triangles. And then the another important step is like vertex shader, which runs for each of those geometry point we define, and we can. This is a programmable stage. As I say, we can control what happens on this stage and what will be the final output of the vertex. Then another stage is important stage is rasterization. On this stage, the whatever we like computed up to now, that's the vertex shader ran and it computed some final position for our square or triangle, right? On rasterization, GPU will go and like calculate how many pixels fall under that triangle or that shape we want to draw, and just generate an image from it. It's just converting vector data into raster image. Then for each of those pixels the GPU got from the rasterization, it will run something called a fragment setter. It's basically a programmable program that runs for each of those pixels. So even if you generate a 4K image or 8K image, the fragment setter will run for each of those pixels. That's a lot of pixels. So you need to have a very powerful GPU for it. So and then after the fragment setter, everything is done like fragment setter. Then after fragment setter, some testing happens. It wants to blend colors or test whether some pixels lie in front or behind. After all that, the final result, that means the image we generated from our initial geometry data, is stored on something called frame buffer. And like the frame buffer is what is finally displayed on the screen or the canvas on the web. And finally, there is something called compute shader that enables general purpose programming. So it's a generalized computation. Then any computation you can think between set of data you can do on a compute shader. It doesn't need to be related to graphics like vector and vertex and fragment, because vertex is for vertices only, that points, and fragment is for pixels only. So basically this is it. Any questions?
Well, first of all, well done, Ashish. Really interesting talk. Can I ask about how does WebGL compare to OpenGL? And is it a lot faster, or how does it compare performance?
So when we talk about like WebGL is based on OpenGL, the mobile version of it, right? These are just APIs. There is no comparison. Like there is kind of like these are APIs, so we can compare between the features they provide or how much access they let us to the hardware. But these are APIs, right? So we can't say one is faster than other technically. But since the WebGL is passed by the browser, so since the browser takes WebGL command and just pass them to some DirectX, Vulkan, or OpenGL command and runs it on the OS. So WebGL should be slower than OpenGL because of the overhead, but these are APIs by the end of the day. I would not compare performance between APIs, two APIs that are basically the same because WebGL is based on OpenGL, but normally OpenGL should be faster because it runs directly on the machine, the desktop, compared to WebGL which runs on the browser. So browser has to do its validation and things before it executes WebGL call. The browser does validation, so any call you make on WebGL is not directly executed like any JavaScript. Or the browser will pass it through some validation layer. It will validate, like it will make sure that you don't do something dangerous with WebGL because there was security problem with WebGL in the past. And then after that only it will execute it. So there's a lot of overhead with WebGL. So I would say OpenGL.
Is there any kind of limitations with WebGL?
Oh yeah, you can't do computes. Like I said, WebGL is. I have like a slide on actually that extras. So we needed WebGL because WebGL was based on OpenGL ES, and OpenGL has been kind of discontinued now because they made a successor to it called Vulkan. So the OpenGL is not updated anymore, and WebGL was stopped. WebGL had no new version after 2.0. It was missing a lot of features. They stopped it there. So and WebGL kind of suffers from all the problems of OpenGL. Like OpenGL has a global state. So all the state you have on your graphics API, they are global. So the states is stored in global context. On WebGPU is not like you can control the state. They can be localized. So and the problem with JS validation, the JS calls, the JS API calls for WebGL are all validated by the browser, and there is a huge overhead on that. And it is recommended not to like call too many WebGL calls. You have to minimize your WebGL calls because of the validation, and that's why WebGPU is the new thing. That's the limitation. And it's incredibly difficult to debug. If you ever tried debugging WebGL, I would say good luck.
Cheers. Thank you, Ashish, for your presentation. It's quite complicated for me, but I just note some question here. So when you write your programming or your code, first question is GPU is using the CPU as well for doing their stuff, or no? Just data or task?
No, the thing is like there are APIs, right? The APIs that you execute, like for APIs are basically function in a library. So you call them from the CPU. So CPU is what prepares the data and does this calling, right? And GPU operates separately. When GPU gets the call, they just talk through some memory map thing. IO or the API is for the driver on the GPU. What implements the API is like your interface, right? What actually implements the API or the specification for the API is the driver on the GPU. So you are just doing API calls to the GPU from CPU to perform some operation on the GPU. Then the CPU operates like its own, like you are imagine like you are sending REST or some WebSocket call to some API on the server, right?
Yeah.
It's just like you send and it will do its own thing. When it's time to get data, it will just send you the data, or you can just query it again for the data, or you can block your thing and wait for it to send you the data. It's kind of like that. It's just a separate system on its own.
Yeah. So actually, CPU decided to
Start the drawing. Yeah.
for data. Okay. So which means if you have a poor CPU with low cores, for example, 2 cores, if even you have more GPUs, it's not gonna help.
It will help because the thing is, you can prepare a huge amount of data. We are like, generally when we draw, right, the data is already saved in the memory. Like, let's say you are playing a game and it needs to load a 3D model. So it loads of model is stored on a file, a set of vertices, set of like points. It will load from a file to the memory, or it can load directly to the GPU memory too. Like there are 2 steps: either load file from disk to directly to the GPU memory, or load file from disk to the CPU memory and then send it to the GPU memory. And then after, like from CPU we can like send data to GPU. GPU also has its own memory. After you like complete this process, you just say GPU drop these shapes, and then it will start this computation itself. You don't need to like constantly keep polling it. It doesn't matter how many cores on the CPU. It will help, like you can draw more things if you have more cores on the CPU, because you can do more draw calls. Like if your GPU is powerful enough, it depends on how many draw calls you can send to the GPU. So CPU is limited by the amount of draw calls they can make, and GPU can draw like the complicated shapes. The CPU doesn't need to generally process the data, but you can like process the data on the CPU. It's up to you. It's programming, right? You can do whatever you want.
My point is, when you write your code, you don't decide this code will use the GPU or CPU. Actually, CPU decided to run this code on this GPU.
No, you decide, because like, we talked about these shaders, right? These are the code that actually run on the GPU. Like these are not running on CPU or anything. It will run on this. Like this.
Okay, I got it.
You can write code specifically for the GPU too, but the data you need to send it, like, because GPU processes data, right, to generate something. So you need to send it. So data you can send from the CPU or directly load it to the GPU memory.
Okay, good. I try to ask some other question because I can see everyone waiting for the things. Yeah. But in the rasterization steps in that popular image, yeah. So you say these pixels are card fragments because they might not be present in the final image. So my question is there any possibility for, I don't know, generate some low quality of the image, the final image, or is it possible to missing some pixels on the original image?
You mean you want to generate a lower resolution image, right?
No, I'm just asking, using this one, so is it cause to have a low quality image or not? There is no things
you specify, like, since we are going from vector to raster, right? You specify how big the image you want it to be. You can set it to be 4K, 8K, 12K. It doesn't matter, because vector can scale to as much as resolution you want. But we are drawing image. You can set the size for the image, the quality for the image, everything. The term like pixel, they are called fragment, but they might not appear on the final image, right? Because they might need to go through some further processing, because in a 3D world, objects are like near and close, right? Something might block other thing. The GPU actually processes pixels for all those objects, even if they block or not. We can exclude it with some algorithm, but it will, in a simplest form, it will draw everything, even if they block or not. So, and at last it needs to check whether they block or not. So before it prepares the final image. That's what that line means.
Okay. So last question. There is another step for frame buffer. So when we say buffer, so there should be any limitation for the buffer size. So when we want to render a large size image, how we go far for using the system resources? Is there any limitation?
That's what the GPU memory is for. Like, it depends on how much RAM or VRAM you have. VRAM.
So I mean, okay, there is a 2 gigabyte image, but I have only 1 gigabyte. It will crash my system or no?
Of course.
Oh, it's bad. I mean, is there any streaming or limited buffer or packet sizing? So, for example, it will using step by step just this 500 megabytes done, another 500.
No, it's not automated process. You control what the size of the final output.
Oh.
It's very low level.
Yeah.
If you want it to be split, like generate like this much size, this much, you
I
do
got
it
it.
yourself because
Okay.
you are controlling the GPU. You are telling GPU what to draw, right? At this level, you can control everything. If you want it to draw some section.
Okay, thank you so much.
Timer? Okay. I was told to put something on my slide. Okay, there is another meetup for backend, and my friend Sahid there, and Guide and Jose will be talking on it. Be sure to come, and registration is free, by the way. And another thing I was told to say, this is not for me, by the way, no pizza if you don't register.
So please give us the feedback. It will take you like 1 minute to complete the feedback, and our team will ask you like there before you get the pizza whether like you already done the feedback or no, and they will ask you to show the screen. So yeah, so please fill the feedback for making a better 7DXPix. Thank you so much for coming tonight, guys. Thank you. Thank you. Have a great evening. Please enjoy the pizza and beers.
Thank you.